defining a variety of parameters. Is it going to be the cost? Is it going to be the reliability? Is it going to be the convenience? Is it going to be the compliance? Things like that. So we put all the information into the big data analytics, and then that will give you, this is the best product from available products that you should buy that will meet all the requirements. Okay, what is the skill required for the data analysis? As you can see, some of these skills are kind of common, but here, very specifically, if I want to go for the data sciences, then I should have the programming skill, which we have already done either in C++ or Java. But then they advise you strongly that you must have knowledge in the R and Python, because they are very important for any data analyst. And again, you should have the statistical skill and mathematics, where you are going to be having the descriptive and inferential statistics and experimental design. That's important because that gives you how you are going to predict. A machine learning skill, again, there are a number of techniques and algorithms. We would like to see that we are aware of that. Data wrangling skill, again, you are going to map the raw data into another format so that you can use the proper analysis technique. And again, you should be able to make sure that you are mapping the raw data accurately. Otherwise, what will happen, that there is a possibility when you are trying to map it, that some of the useful information may be lost. So we have to be very careful whenever you are doing the mapping. And communication and data visualization skill, again, we would like to put the data in a different format. I mean, especially if you are looking for the multidimensional data, then you are using lots of variables. And so whether you are using the colors, or you want to have the bar, or you want to the chart and things like that, there are different ways by which you can visualize the data, because it becomes much easier for us to see how the data is changing. And that way you can make a prediction based on what you are going to be doing next. And then, of course, data intuition, that's extremely important, that we should be able to think like a data analyst, that this is what we think. So it is coming like from intuition. This is what I think data should look like, and this is what it is going to come up. And that's where we certainly expect that something should come out from your side, that I'm really doing the right thing as a data analyst. Okay, again, Python coding, you should be very comfortable with that. Hadoop and Spark platform are the one which are very popular nowadays. Again, but they are very complex. But these are the only two tools right now. They are of course, there are a large number of tools, but these are the two which are very popular. And why we are using them? Because this big data cannot be used on the traditional databases. I cannot use the Oracle. I cannot use the MySQL. I cannot use the DB2 for this big data. That means which is structured, unstructured, and semi-structured. I cannot, because they do not have the storage, and they do not have the processing capability. And while these two platforms, they have got enormous amount of space and enormous amount of processing power, which can be given to variety of data which we are collecting from different sources, as I just mentioned. So we should also have little experience with the SQL database coding. And again, whether you are using the SQL or you want to use no SQL, these are the two. They have become very significant part for the data science background. And still people prefer SQL, but there are some cases where you prefer the no SQL. And especially when you are working with the unstructured, it's very important. It's very important that we are doing the mapping very accurately. And again, the data is coming from social media, video feeds, radio, audio, and things like that. So we have to be very careful to see that we are able to capture the data correctly. Another discipline which has been introduced is a data engineering. So we have got a big data analytics, and then we have got the data sciences, and now data engineering. Again, they're all kind of related one way or the other, but again, people are defining different discipline, so that in case you are not interested for the data science, you can go for the data engineering, or you are interested for the big data analytics, you can go for that. So data engineering deals with collecting and managing the data, and it is based on the concept of ETL, extract, transform, and load. That's what it does. It does not go beyond that. It does not do any analysis. It only creates a model for you, and use that model and do your analysis technique to see information you are interested in to get from the data. And again, this is a scalable, and prediction can be done on demand. What we do in the case of extract, these are the sources of the structured, semi-structured, and unstructured data. So existing database. So I can always go to existing database, get all the data, or I can go to the cloud. I can go to the hybrid or on-premises, sales and marketing applications, mobile devices application, CRM system, data storage platform, data warehouses, analytical tools. I mean, I can go anywhere. I have to simply extract the data. So right now we are only getting the data from there. We are doing no analysis. We are simply getting the data from these different sources. Once it is done, then what we do, we transform them in a particular format. So we have to make sure that we do follow the following process. So we have to do some kind of cleansing. That means any value which is missing or any inconsistency has to be removed at this time. And again, I can either use the standard formatting if they are there. If not, then you can use whatever formatting you have got. We have to make sure that if there is a duplication, then we have to remove or discard redundant data at this time. If I don't do that, what will happen when I do the analysis, it will take more time because it has already done the analysis for the data and the same data is occurring again and again. So there is a duplication of the data. So we have to make sure that any duplication or any redundant data should be discarded at this time during the transformation. And then we have to make sure that we do the verification. That means you're verifying that you remove only unusable data, not the usable data. By mistake, if I have remove the usable data, then you are going to miss that pattern, or you are going to miss that useful information into the data. And then we do the sorting for all these data. Different categories of the sorting is being done for the data. And then other tasks are any guidelines, rules to improve the quality of data is what we have to do in the case of transform. Once it is done, then we load it. There are two methods by which you can load. Either you can have full loading or you can do the incremental loading. In full loading, basically you have got the entire data which is going to be loaded one time. So obviously, as you can imagine, it is going to grow the exponential. And it can also become difficult to maintain. And warehouse is going to become a big problem. So what people do is usually that they will have incremental loading. So they will have little loading of model, whatever they have got from the extract and the transformation. And then they are using what they call as a manageable approach. So once it is done, then they compare the incoming data with the existing one. And they say, okay, now we have got a unique record. And then we say, let's go for the new one. And then they find new one, and then they go for. In this way, they can easily discard anything which is a duplicated, or if they find there is a unique record which has been generated from here, they are the one they are going to load, and it is not, then they are not going to load it. So this is very important after the transformation, that we have to make sure that we only load those data and then compare with already data which is there, so that we can only produce the unique record rather than the simple record. Okay, then I did mention about the analytic. So now question is, what is a big data analytic? So big data we have already defined. Now we do some kind of analysis. So this is the process of examining large and varied data sets to uncover hidden patterns, unknown correlations, patterns, market trends, customer preferences, and other useful information. As I just mentioned, with the help of those applications, these are the things which are going to be detected by the analytic method. So, and again, it does handle with the very large data, and then these data are coming from different sources, as I mentioned here. And then for the big data solution, typically these some of these tools, they are available as open source. For example, Apache Hadoop. Open source software is available. You can also look at the Apache Spark. You can use the Apache Spark. So they are available as open source. But again, you cannot get those sources. You have to go through the licensed vendors, and then again you have to get the training before you can start working on the big data analytics. So what are the different phases for the big data analytic, and what we call as a processing pipeline? So first is the data acquisition and recording. Second is the information extraction and cleaning. Then we do the integration, aggregation, and representation. And then we do the query processing, data modeling and analysis, and then finally the interpretation. So these are the 5 steps. Each of these tools, which I just mentioned to you, Hadoop and Spark, they follow these 5 processes in the pipeline for doing the analysis. So question arises, why should I go for the big data analytic? Why it is important? What if I don't do that? You have collected the data, you have stored them, and you did not do the analysis, or you did the analysis in a wrong way. So what is going to happen? Nothing. You're not going to get anything. So when we want to do the analytic, it is important because we want to get the immediate insight, and we would like to resolve incidents faster. We would like to use it for cost reduction. We would like to make a decision faster and better. And also, we think by doing this, there is a possibility we might create some new products and services from this. So these are the reasons why big data analytic is very important, that we have to do that. A question is that if I don't do that, certainly you may get the information, but that information may not be accurate, and you may not get these different advantages, what I have shown in this slide. Typical topics in course on a big data analysis in any universities. Again, we would like to identify the objectives, that this is the objective of my course. Students should have the knowledge of big data analytics and enhance programming and mathematical skill, and they learn to use essential analytic tools such as Hadoop, Apache Spark, and R. And these are the different topics we covered in the course. My university is also offering a course on this, and so these are the different courses we cover: cloud-based big data analysis, predictive analytics, probabilistic and statistical models, application of large-scale data analysis, analysis of problem space and data needs. Okay, so we hope that once you have taken this course, and you'll be able to approach large-scale data science problem with creativity and initiative. Again, there is no guarantee, but we do give them small projects, and we have seen the students, they're really very much interested, and the most difficult part we are having is getting the data set. So we contacted the Google, we also contacted some other companies, and then somehow we are having hard time to get some of the data from them. But then we also went to Department of Energy, and from there we were able to get some data set, and with the help of those data set, we can certainly do some analysis and then see whether we are getting the same result what these people have done. So they know what result they are getting, but we want to see whether we are getting the same result or not. So this is what we think, that if you have taken the course, you are going to learn how to develop algorithm for the statistical analysis of big data, how to use fundamental principles used in predictive analytics, how you are going to evaluate and apply appropriate principle, techniques, and theories to large-scale data science problem. And of course, you are going to have a knowledge of big application. What courses you should be taking if you want to go for a degree in data science? Again, this list may not be accurate for all the institutions. Different institutions, they have got different courses, but we think that if you are taking a degree in data science, these are the courses they should be included in one way or the other: algorithm design analysis, scientific computation, software engineering. Again, I have given the list of all the courses here. Okay, then we come to the software tools for the big data analytics, and these tools and software basically are used for only storing the data and doing the analysis on the data. And when I said analysis, means that these data are going to be processed. So it gives you the storage. At the same time, it also gives you enough processing power so that we can capture the data from the memory, and then we process it using the cluster of nodes. I'm going to show when I come to those tools in a moment. Okay, and why we are doing that? Because the traditional database, as I mentioned, they cannot store and process these huge amount of data, and also they cannot handle the unstructured data. Okay. So here I've given these different categories of the tools. So if you're looking for the analytic tool, these are the Apache Hadoop, which I mentioned, Spark. A tool. There are some tools for the visual programmers, Scratch, Microsoft Visual Studio, NetLab Toolkit. I think most of you are familiar with that. Programming skill, we expect that Python, Hadoop, R, Java, they certainly should be there, and these tools are available, so we can make use of them. Okay, now I'm using these analytic tools, and question arises, which one should I use? I'm not sure. Which tool or software should I use? So these are some of the questions I'm going to ask to myself. One is that capabilities of the tools and software, hardware, software requirement of the big data tool, the cost involved in the training employees on the tool. So let's say if I own a company and I want to buy one of these tools, what should I do? So these are the factors I'm going to consider before I buy any tool from the market. Quality of the customer support, license cost if applicable, support and update policy of the big data tool vendor, and reviews of the company. These are the various factors I'm certainly going to keep in mind before I decide to buy any particular tool. So let me give a very brief introduction about two tools which I have been mentioning to you earlier. One is the Hadoop. Started from Yahoo project way back in 2006. And again, it is based on the distributed processing system. It defines a cluster of nodes, and it has got distributed file system. We call that as a Hadoop distributed file system. So every file is broken into blocks, and these blocks are replicated on different nodes. And then from there, we create what we call as a distributed file system. So we are using the same concept as we are using the distributed system. And again, the open source, as I mentioned, is available through these different distribution vendors. So we cannot just go and get the source code, but we have to go through these vendors. And there are two vendors. One is a Cloudera, and AWS are the one which basically allow you to have this Hadoop. It's a highly fault tolerant because they are not using one node for storing your data. The same data is being stored on cluster of nodes. So if one node fails, it goes to the second node. If second node fails, it goes to the third node. That's how they are able to create what they call as a fault tolerance system. Okay, and so each of these files is broken into blocks, and these blocks are replicated on number of nodes. And they are using the Kerberos, and that certainly offers the security controls for the HDFS. These are the four components of Hadoop: MapReduce, HDFS, I just mentioned about this one, Hadoop distributed file system. So every file is broken into blocks, and these blocks are stored, replicated, and they're stored on a different nodes. And MapReduce has got two subroutines. One is what they call as a job tracker, and second is a task tracker. What this task tracker does, it goes to all the nodes, find out, do you have any task for me? And they say, yeah, we do have a task for you. So then task tracker goes to the job tracker that, I've got a job for you. So job tracker says, not a problem. He goes to Yarn. Yarn provides a different types of architecture, and it provides all kinds of resources. So the job tracker goes to the Yarn and say, I need the following resources. And from those resources, I should be able to process these tasks. And all these tasks are processed in parallel. So it is totally based on the parallel processing, but at the same time, the file is being distributed across the memory. And then we have got Hadoop Commons. They provide all kinds of APIs or libraries, so that we can provide the interface between MapReduce, HDFS, and Yarn. So all these interfaces are being provided by the Common. They also provide a variety of APIs. So any data which is coming from any source, let's say I want to go to the traditional database, I want to capture the data. So then I got API from the Common. I go to the database, capture all the data. That data goes to HDFS. Once it's stored there, then MapReduce says, okay, I'll go there, collect the data from the memory, and then process it. And once it is done, it goes back to the HDFS and store the data back into the HDFS. So in this way, this Hadoop provides storage in the form of HDFS and the processing in the form of MapReduce. And Yarn provides different cluster of nodes depending on the resources you want. So I can make a request for 64 nodes that will be provided by the Yarn. So they are going to create an architecture for the MapReduce so that those tasks can be processed on different processors. The Spark is another one which was introduced in 2012 at UC Berkeley. And again, but the only difference between this and the Hadoop is that in Hadoop, we have got HDFS. While in this case, it uses the data in RAM. And they're using the concept of resilient distributed data set. And this is the one which is capturing the data from the RAM, and it does the processing through RDD. So RDD basically provides everything, not only storage, but also the processing. In other words, Spark can run as a standalone, or I can use this Spark on the top of Hadoop. So it can go to Hadoop, get the data from HDFS, and then it can process using RDD. And once the data is processed, it can send it back to HDFS. So it can also be interfaced with Hadoop, and also other tools which are available. So, for example, RDBS and other tools can also be used here. It has the fault tolerance. Again, they are using the RDD operations, and it is using the same Kerberos authentication to make sure that all the files are secured, and it has got lots of machine learning library algorithms. And again, it's a very iterative machine learning application in memory, because every data is in RAM, while their data is not in the RAM, it is in the HDFS format. So it's available in Java, Scala, Python, or R, and again, it uses the classification. That's another thing which is very important for the big data, that I should be able to classify them in different categories so that we can use the regression and we can reduce the noise from those data. So it provides a variety of machine learning algorithms. There are several libraries that operate on the top of Spark core. Again, I've given some name. Again, you can get all the information from the Google. It has got several APIs. And here is a diagram of Spark. So the core, you can see that core provides the scheduling, and streaming is the one which is the actual live data which is going to be processed. And then Spark SQL provides the query which goes there. And then ML library, machine learning library, has got lots of API. And of course, the graphic is being provided by this component. It has got 5 components shown in the diagram. How much time do you have, Dr. Mishra, at this time?
Time you need, sir? How much more?
I think I should be done within another 10 minutes at the most.
Okay, sir. Please continue.
Okay, thank you. Okay, now I will just mention about the research topics in the data sciences. And again, I was able to collect a big list, but I have only selected a few lists so that at least we can see what people have done, what are the different techniques, and still we can work on those different techniques. And idea behind each of these topics is that how can we improve the quality and the performance of those different techniques. One is a data visualization. Here we would like to see how we can present the data in a different format. And again, the data is coming from different dimensions. And again, if I got a data with a multi-dimension, it becomes very difficult to analyze that. So how can we reduce the dimension of those data? How can we reduce the number of variables? And how can we plot the data in a particular way, either using histograms or box or plots and things like that, or whatever you like, so that we can see them clearly. And then again, we can also assign the colors, different sizes, shapes. You can have some kind of animation. Again, that is very important? Not really, but certainly it does help a lot when you are doing the analysis for the data which you have got. So we get the data, and then we convert into the model, get all these types of presentation based on where you are more interested. So we can have the colors, we can have the size, and then we only go to that particular data and try to analyze to get the information. Second, we have seen that more and more people are involved in doing what they call as a dimension reduction method and the techniques. As I mentioned, that we have got large number of dimension in the data set. We would like to have less number of dimension, because if I have got more number of dimension, it is going to take a lot of time for the analysis. So we are trying to come up with a technique by which we can reduce the number of dimensions. And there are a number of machine learning and statistics techniques which can be used to decrease the number of random variables. And in particular, some of these techniques which I'm highlighting here are the one which are very popular, and people are still using those techniques and trying to see how can they can improve their performance. So these are some of the techniques which has been used for performing the dimension reduction: missing values, low variance, decision trees, random forest, high correlation factor analysis, principal component analysis, backward feature elimination. These are the standard techniques which people have used, and still people are using these techniques to see how these techniques can be improved for the performance. Classification, as I mentioned, is a core for the data mining because we would like to classify the data. And again, the idea behind this is that so that we can use the accurate method for the analysis and the prediction from the data. If I do not classify the data, so I have got big data and I have to classify that, okay, this data belongs to this class, this data belongs to this class. And then I go to each of these classes and I can decide the accurate analysis technique. And that technique is going to give me a better prediction for that data, what this data corresponds to, and what this data is going to give you in future. So these classification problem has been defined, and there are a number of methods they have used. They're trying to extract and prepare the data, build the classification models, evaluate models. And so linear and non-linear classifiers are some of the key terms the people are using. So either they are using the linear or the non-linear classifiers. Again, people have used it a lot, and depending on what type of application you are working on. So these techniques can be used, and they will certainly help you to use the accurate analysis technique. Next is the linear regression modeling. Again, we have to make sure that the model which you are using is very simple, but at the same time, it should also support the multiple regression. So linear regression models are among the basic statistical model for studying relationship between an independent variable and dependent variable, so X and Y. So it is a mathematical modeling which allows you to make prediction and prognosis for the value of Y depending on the different values of X. And there are a number of techniques for the linear regression. These are simple linear regression model and multiple linear regression model. And key points here are terms such as we have to find out the correlation coefficient, regression line, residual plot, linear regression equation, and so on and so forth. These are some of these techniques which have been used. And again, people are making use of those techniques in one way or the other to different applications. Neural network is another one. In particular, the artificial neural network is also is being used in some of these big data analytics. Again, they're trying to see how can we define the artificial neurons so that we can train the system. We can train the system, and then they can learn from the data pattern and execute functions like classification, regression, prediction, and so on and so forth. So for these different issues, people have also used the artificial neural network so that once we see the type of data, we have classified them, and based on that, the neurons have been trained, and then that same neural network can be used then to do the classification for other data set, and so on and so forth. Again, people are saying that this is a kind of deep learning technologies used for the solving complex signal processing and pattern recognition problem. Again, they have got different terms they're using, perception, back propagation, half-field network, and things like that. These are the different words they're using in the neural network. And again, I did mention about the cleansing. So there are some techniques we have to use for what we call as a smoothing. And there are a number of approaches people have used, because when you collect the data, there would be a lot of noise. So we have to make sure that we remove that noise, but at the same time, we have to be careful that we do not remove the useful information from the data. So there are a number of algorithms people have come up so that they can use on the collected data, and then only it takes the noise away from the data set, so that you can do the analysis. If noise is not removed, then what will happen? The analysis may not give you the correct result. Okay, so it should be used to help predict trends such as those found in the security prices. There are different methods in which data smoothing can be done. Some of these include the random method, random walk, moving average, simple exponential, linear exponential. And these are different methods by which the smoothing can be done on the data. The fraud detection using AI is another one where people are doing a lot of work, and they're using the machine learning approach to see if they can detect any fraud, and so that then we can decide what kind of security measure we should use for our system. It also gives you differences between machine learning and the rule-based approaches, because AI is based on the rule-based, and machine learning gives you predictive analysis. So we would like to see how they can be combined together so that we can detect the fraud. Okay, now going through all these slides, I'm convinced that big data analytics seems to be a good area that I should choose for, or maybe a good research topic I can work on. because I do see that these are the things, but there are a number of issues and challenges in big data environment. One, of course, is the data growth. So whatever I'm doing today, tomorrow the data is going to grow exponentially. So today I'm working on data which is, let's say, 4 million. And tomorrow, or maybe after 1 month, it has become from 4 to 10. So now my problem is that, is my model going to take that amount of data which has gone from 4 million to, let's say, 10 million? So that's a big issue. Predicting and generating meaningful insight in a timely manner. I mean, if I give you time, like I want all the information in 1 day, can I do that? Certainly, it will take some time, because I myself, I'm not sure whether I know everything about the analytic tool. And also, I'm not sure about the type of data which I'm using to see if I can come up with a meaningful insight. Getting huge amount of data into big data platform is a big problem. And then integration and synchronization of disparate data sources is another big problem. I mean, I'm getting data from different sources. I mean, it is coming from this sensor, it is coming from that sensor. Can I integrate them? Can I synchronize them? Because they are working on different clock pulses. Uncertainty of the data management landscape. Validating data. I'm not sure whether I do have any validating technique here. Can I ensure, can I say for sure that whatever data I'm getting has been validated or it is accurate? Data storage and quality. Of course, Hadoop and Spark, they do have enormous space, but still we are not sure whether that storage is going to give me good quality of the analysis. Security and privacy of the data is another issue people are still working on. Integrity of data, I'm not sure whether the data is going from one module to another module. Is it going to be maintaining the integrity? It is not going to be changed. I'm not sure. Delivery of relevant information on time, lack of technical skills in employees. I mean, my boss tells me, just work on that. And we don't have experience. So, we have to ensure that all the employees, those who are working on that project, should be aware of how the tools are being used and what exactly is needed from the big data. Willingness over acceptance of business analytic by staff. Data security and maintenance. Cost involved in implementing BA is very enormous. I mean, do you think that my company can spend that kind of money? No, they cannot. So they'll prefer to go for outsourcing rather than doing by themselves, because these tools are very expensive. And then again, they require a lot of training before you can start working on that. Investment of staff time in implementation of BA, lack of proper strategy to implement BA. So these are the different issues and challenges right now we are facing. And as a result, although it looks very nice that we should be working on that, do we have any solid application which we can claim that really convinces me that I should go for the big data analytics? And answer is not really. People have used it, but they're not using it 100%. They're just like 60%, 65%. So collecting meaningful and real-time data is another problem. Visual representation of data, poor quality of data, confusion or anxiety, budget, scaling data. Now these are different issues and challenges we are still going to have. But that does not mean that we should stop looking at this technology. This technology is definitely going to come. And if I look at the Amazon, they are using lots of these tools for selling their product. So I think once that becomes very kind of standard, then probably other organizations or other industries are going to follow from here. So I'll just give you two case studies which have been done recently. One was done for the election in the United States. What they did is that they did gather the information and they perform sentiment analysis. That's another kind of technique which is being associated with the big data analytics. They call it a sentiment analysis. So they're going to look at how the sentiments of the voters can be predicted. Now, again, it's very difficult because I may have little sentiment today. I may say something here. I may have something in my mind today. Tomorrow, I may change it. But they are using those analysis techniques to see if they can predict that this is how the sentiments of the voters are going to be during the election. Gather the comments, opinions in social media. This is where people are more interacting, especially we all know that Trump, used to do a lot of tweeting, and he used to spend a couple of hours doing, sending the information on the social media. So he likes the social media. So again, by going to the social media, we can look at the election campaign and candidates from the demographic parameters like race, age, gender, political affiliation, and many others. And using these data, plot a trend line showing sentiments rise or drop for the candidates, and visualize complex data that will be used by political strategists and political journalists. And actually, they used this in last election, and they found that results are kind of not exactly what they wanted, but it was closer to what they expected. Like, they say, yes, yeah, I think we got like 75%, but not 100%. So that means there are certain parameters which they did not consider for this particular case study. And then they designed the machine learning models that will gather the information from social media, channel, poll surveys, etc., to provide trend charts, voter maps, voter sentiments based on social media channels, things like that. So they did that. Is it a successful case study? Not really. They did find a lot of flaws here. So they are working on that, and hopefully in the next election, probably they are going to use it again. And second case study, we see one gentleman wanted to have the coffee shop, a tea shop. So he said, what should I do? I want to use the big data analytics and I want to have this shop. So what do I do? So he collected the data and then used the analytics for deciding this is the location where the tea or coffee shop should be located. So he look at these different data, number of the people around that area, the competition, easy access to your shop, number of parking spots, number of employees to provide these services, timings of the services, quality of the service, waiting time, marketing strategy, customer feedback, and so on and so forth. But some of these parameters are the one he basically used that, and he's got a big list of variables. Based on that, he was able to show that the shop which I decided that this shop is going to be at this location certainly is giving me a good profit compared to if I would not have collected all the data. So I think these two case studies certainly convinced me that I should certainly go for the big data analytics in one way or the other, whether I should take some courses or I should, start working on these Hadoop and Spark tools to just get experience and knowledge, and also going for the programming like Python and R, things like that. So hopefully, if everything goes right, over a period of time, maybe two years down the road, 3, 4, 5, I do not know, I have no idea, but I think probably people are going to be convinced that this would be the area in which is going to be there for a few more years. Some of the references, again, my papers are kind of old. I published these papers in 2016 and another one 2013, but I have taken some of these images and some definitions from the various websites. With that, let me stop here and thank you very much, and I'm open for question and answer.
Okay, sir. Thank you very much for your nice elaboration on the topic. I think this was the very intensive and very knowledgeable lecture you have delivered. So if you have Sangharshi, you can take some message if there are questions. And if there is no question, then I can have one question from Professor Huda. Is any question? Sangharshi? Sangharshi? Okay, so Sangharshi?
He cannot hear you.
Anybody wants to ask any question? Okay, I think he is disconnected. Okay, sir, I would like to know for the beginners and for the, students, for the faculty members who can go through properly the concept of the data analytics and beginning from basics to the some advanced topics. I would like to know the name of the book and author, if you remember any standard book. Which
Actually, there are many. There are many. The top of my head, I don't have, but I can certainly send you the list of those authors to you. And if you want, I can send these slides to you so that in case you want to use them as a reference, they will be helpful to you.
Okay. That should be, average book so that the students of the, who come from the rural areas of the.
Yeah, sure. For the programming, let's say if you want to go for Python or I usually encourage my students, just to go to the YouTube.
Okay.
because they have got a very nice tutorial for all the programming languages. So whether it's a Java, C++, I certainly encourage all my students, that, of course we are teaching in the class, but I tell them that, if you make use of the YouTube, they have got a very nice tutorial. They have got a very nice tutorial on the programming languages. And I think there are some YouTubes, if I'm correct, they do talk about the big data analytics. They do talk about the data sciences. So there are some, good YouTubes. If you just type data sciences and go to the YouTube, you'll find a number of YouTubes are there.
Okay,
and that also will help you, at least, to start with, because, maybe I think this time probably not many people were able to attend. But let's say if you want to teach that course in the class, I think I use, typically this is what I do. I hardly use any kind of textbook in my courses, especially the graduate level courses. I just go to YouTube and I find some nice YouTube. I tell them go there and listen to that and submit the assignment. That's what I do.
Okay. So thank you very much, sir, for your nice cooperation, and you have given your full time, and you also connected on the time. So once more, from the inner of my heart, bottom of the heart, I just thank you and express my thankfulness to you, whatever time you have spared and your energy you have given to the department. So keep on giving your cooperation in future too.
Sure, by all means.
You visit the India, then you inform me. I will take you to visit to get you visited this place of Sri Ram land.
Sure.
At the Rama land.
Ayodhya. Oh yes, yeah. That would be my pleasure. If I come to India, certainly I'm going to visit that, because that's how I can pay my respect to Lord Rama.
Okay. So thank you once more. Thank you very much, sir.
Thank you, Mishraji, for giving the opportunity to share my views with your audience. Okay. And I hope that I was able to explain everything. And in case you need anything, let me know. Don't hesitate. I'm always there to help.
Okay, sir. Okay. Thank you very much, sir.
Hey, thank you, sir. Have a good day.
Okay, sir. Thank you very much.
Okay, bye-bye.
So we have next speaker. I think she is connected for last 10 minutes. Madam, please, yes. We have with us our next speaker, Professor Carol Hargreaves. Do you hear me, madam?
Yes, I do. Thank you.
Okay. So you were waiting. I am sorry that this previous lecture was a little bit late.
It's fine.
Speaker was asking for some more time, so you had to wait for your lecture. So she is a very versatile professor, and she has knowledge from different areas. We can say she is expert in interdisciplinary studies and approaches. So for formal introduction, I would like to request Mr. Sandeep to read her bio so that we can understand her areas of the interest, and thereafter we will start the lecture. Madam, you will share yourself, or you need our help?
I'll share myself, thank you.
Okay, thank you. Sandeep, you please unmute yourself.
Am I audible, sir?
Yes, but you are Sandeep.
Yes, sir. Yes, sir.
Okay.
Professor, just a minute. Professor Harris,
आप तो दो इंस्ट्रूमेंट जोड़े हैं क्या संदीप?
It's clear. Am I audible?
Okay.
Sorry for that, sir. Professor Carol Hargreaves, PhD in mathematics, and she has also done MSc in mathematics and BSc in statistics. And Professor Carol, in May 2002 to 5, she has received a biostatistician, the University of Sydney, and after 2011 to 16, she has received Chief of Business Analytics and University of Singapore, and July 17 to present. and she is also director of the Data Analytics Consulting Research Center, July 2017 to present. Now, I would like to request Professor Carol to present her topic, and her topic is deep learning scoring algorithm for the radiographic joint damage from rheumatoid arthritis. Thank you, sir.
Thank you for the warm introduction, Sandeep, and thank you, Professor Mishra, for inviting me to present today. Allow me to share my screen. Okay, so just a little bit more additional information. So I lecture data science in practice at the National University of Singapore. I also supervise several students in their final year projects where they do projects with industry or research projects. And what I'm going to present today is one of the projects that I worked with my students, where they worked on deep learning to classify X-ray images for rheumatoid arthritis. So basically, currently in the clinical field, you're finding that clinicians, radiographers are the ones who are scoring the X-rays. So what we are trying to do, or what we have done, is to build algorithm that is able to look at the X-ray, score the X-ray, and then of course guide the clinician or the radiographer on the state of the damage of the rheumatoid arthritis. So this is the rationale. Rheumatoid arthritis is a disease that causes joint damage due to inflammation of the soft tissue that lines the spaces of the joints. And it actually affects 1% of the world population. So what is the issue? The issue is that currently the radiographs, as I mentioned earlier, they're manually reviewed, and also they are not quantified. So it's more subjective in the nature of the clinical practice. So our aim, as mentioned, was to develop an algorithm that can measure the degree of the joint damage quickly, accurately, and consistently from the radiographs of the hands and feet, so that it can be used in clinical practice as well as for research purposes. So I will go through as background information before I go to the actual modeling. I will briefly give background information on rheumatoid arthritis. I'll then look at how the scoring of joints are done in the clinical practice, and then give a description of our data before speaking about the modeling process. So what is rheumatoid arthritis? It's an immune system that mistakenly attacks the body's own tissues, and it results in inflammation and joint damage. And this is a picture that can help you to understand what's rheumatoid arthritis. You can see even the first picture on the left, there's inflammation in the fingers, right, in the joints. This is early stage rheumatoid arthritis. And late stage, you can see that it's even far more different in terms of the joints. And at this stage, a few of the activities the person will not be able to do. Some simple things sometimes is putting on their clothes or tying their buttons and so on. So it's quite serious in terms of the impact of rheumatoid arthritis to the patient's ability to do everyday living tasks. So you find that the external symptoms are red, they're swollen, and also accompanied by pain. So usually some sort of treatment in terms of from pharmaceutical companies are given to the person with the rheumatoid arthritis to help to remove the inflammation, which actually helps to remove the pain. So how do we know whether the person has rheumatoid arthritis or not? There are inflammation in the joints, which cause the cartilage to erode. So you can see in this picture on the left, right? This is actually a normal joint, but you find that as the amount of cartilage decreases, you find that there is some erosion, right? So yeah, you find some erosion, as well as you find that there's narrowing of the joints. So we can see it's very different from the normal to the person who has damaged joint ori. So as a result, because the bones are so close together, they will actually rub together, and that's where the inflammation starts and the pain will take place. So the bone, right? The bone erosion is actually happens over long term, right? And we also find that the most common destruction is joint erosion as well as joint narrowing. So we get scores for both joint erosion, joint narrowing, and then overall damage when assessing the structural damage of the X-ray image. And in clinical practice, they use a method that is called the Sharp van der Heide method. And this method looks at the specific joints in the hands and the feet. Each joint is scored on its degree of narrowing and erosion by an expert, a radiographer, or some clinician. And then the overall damage score is obtained by summing up all the scores for all the joints. And for this to happen, experts take several days to review the X-ray images. And the scores also tend to be varied between clinicians because it's somewhat subjective. It's a visual scoring of the joints. So what actually happens or indicates, how do we know someone has the rheumatoid arthritis? Of course, it depends on this joint score, the Sharp van der Heide score. The higher the score, the more severe is the joint damage, the more is the disability. And moreover, we'll find that for the scoring, actually in Singapore, there are very few clinicians that actually do these scorings. And on the picture at the bottom, it actually shows you all the joints that need to be scored by the algorithm. So for the foot, right, you can see that these are the narrowing scores where they use the MTP score. Then on the left hand, we can see they use the PIP scores as well as MCP scores. And then we give you an example for the foot again, MTP scores are used, right? But these are for erosion, whereas the first one was more for the narrowing. So as you can see, there are many joints that need to be scored, and the higher the accuracy, the more the overall score, or the better the overall accuracy for the whole hand or the whole foot. So the data set that we used had a total of 364. So 364, we can call them patients for now. And for each patient, there were 4 radiographs. So one left hand, right hand, left foot, right foot. And these were provided to us in JPEG files. And we also, within the file, we also had the SVH scores so that our model could also learn from the X-ray and the score to be able to transfer so that our algorithm on its own can also score the X-ray and come up with a similar score to the SVH. So, so that's just a quick introduction to the problem that we worked on. Now I will move on to the deep learning methodology. We look at how the joints are segmented and how we score it using the algorithm, and also the evaluation of the joint scores. So this is sort of a very top level on the process that we use. We, of course, like for any analysis, we have to do pre-processing. In this case, we'll make sure that the X-rays are of the same size, which means we need to crop and resize. And once they are all of the same size, or sort of a standardizing that we do, we then mask. I'll show you later a little bit on each of these processes. We then mask we use a UNet. And then once we mask, which means we have the full shape of the image, the region of interest, we then identify the joints. And once we identify the joints, we need to extract these joints for further analysis. And we use the YOLO V3 to do that. Once the joints are extracted, we then use a transfer learning, which it's a large database of images already classified. We apply this VGG methodology to actually transfer, and we enhance our scoring. But our base of our scores are done from the transfer from the ImageNet database, and then we then modify and fine tune our parameters using VG16. And then we, of course, once we have the joint scores, we then need to evaluate how good are the joint scores, because we already have the scores from the clinicians. So we need to measure the performance of our algorithm. And basically it's the normal, we'll use so the overall scores are done in terms of a confusion matrix, because the joint scores, even though we use the SVH score for measuring the joint and the amount of narrowing, the amount of erosion, that is then converted into scores of 0, 1, 2, 3, 4, which is categorical variables. And so that's why we use a confusion matrix to understand the overall performance of our algorithm, because the end result is the level of damage that we actually report back, even though we use the SVH scores. So I spoke about masking. So just to give you a better idea on what is masking. So masking is you can see this is the regional X-ray, and then we can see how when it's after it's masked, how it looks. So it gives you a much more defined shape of the region of interest, right? And so the first one is of the foot and the second one is of the hand. So you can see it's much more clearer what is the region of interest. Once we have the masking, we next need to identify, right, the joints, and we need to actually extract the joints. So we use a UNet, which is a typical convolution neural network architecture that expands for a few changes, right? So you find it actually compresses, right? And it's almost using like a latent structure in the middle. So it compresses the information, and then it's able to then expand to its original. In this process, you'll find it's able to identify, right, the actual area of the damage. So while we have the full hand, for example, it will be able to pick up by the joints via the actual damage areas. And then we use a YOLO V3, which means you only look once, right? Okay, we did this about 2 years ago, so of course I think there's a much higher version at the moment that's out. But it's a real-time object detection algorithm that identifies specific objects, whether it's in a video or live feed or in images. In our case, we're using images. And it detects, so in this case, it will detect the joints. So we can see on the figure in the right, it will detect where the joints are. And then the beauty of the YOLO V3 is that it can do this identification of the joints in much less inference time compared to other technologies. And also that it learns very well when it comes to representations of images, and more specifically in radiographs, it does it quite easily. There wasn't any problem in applying the YOLO to the hand images. And the results, just from using the YOLO, we found that the results was 99.9%. You usually think that's just not possible, but this is just how good the YOLO is in terms of the joints. Out of 11,114 joints, it only identified one wrong. So only one was identified wrong. So that we were very happy with the performance of this task. And then, of course, I spoke earlier about the transfer learning, where we use, there's a big ImageNet database where the weights of different images are all available. We use that ImageNet, and then we apply our model. So we transfer those weights into our model, and then we further fine-tune our model so that the weights become more related and relevant for, let's say, the joints in our hands. And there's the structure, architecture of the VGG, those of you who understand it. And we find that through that, we're able to actually predict the scores of, because through the weights, we are able to predict the scores of the narrowing and the erosion for each of the joints for the patients. So in terms of results, right, of our algorithm, we use the balance test accuracy, right, and that was 78.77% for the hands. And then we used a little bit plus minus one balance test accuracies when we grouped the neighboring scores into one category. So if we have a category of 1, then we will group 0, 1, and 2 as a category, and then look at the accuracy. And we found that, and this we saw in another one of our research papers that we did a literature review on. They actually did use this method, but they found that the accuracy was 82.5%. And this is also on the hands and feet x-rays. And they had 10 more times data. So this 94.63%, we were quite happy with, because we thought it, of course, performed much better than previous work done. Then in terms of the erosion of the feet, right, the feet were a bit harder to get high accuracy, but the balance test was 57.83, but with the plus minus 1 balance test score, it was 92.49%. Then with narrowing, we found that the balance test accuracy was 82.07%, and the plus minus 1 balance test accuracy was 97.30. With the narrowing of the feet, much better than with the erosion, because the accuracy was 83.76%. And again, for the feet, the accuracy was slightly lower than the accuracy for the narrowing of hands, 91.51%, but still a good performance. So what were the challenges? There were quite a number of challenges. One, there were overlapping joints we found. So we had to try and separate those. We also found sometimes they were, like, the skin was also interfering with the joints. It wasn't quite clear in picking up the joints. In some cases, the images were too dark, and sometimes the images, they came already cropped, so sort of cut off slightly. And in some cases, of course, we even found the presence of anomalies like rings on the fingers, which also distracts the overall accuracy. It's difficult to actually see the joints and so on. So part of the cleaning process, we had to remove these anomalies. About future work and possible improvements. So we had 367 patients in our data. We think more data would be much better. And as you saw in a previous study, they had 10 times more data, so 3,000 images. So we feel with more data, our accuracies, our results will improve. We also, we're currently validating our results, right? So we're actually working with clinicians by they giving us their data, and we are validating how good our model performs on their images to, and for them to also give feedback on how in clinical practice it's used, and so how our model can also improve so that it can be used in the clinical setting. So we've just started that now. And then once that models have been validated, our next step would be to build a technology whereby you'll have the GUI, the interface, and it will be more easier for clinicians to use than the state it is in currently. Because currently we have the algorithms, and so we need to put interface for user use. And we also feel that future work, because similar to how we are measuring and understanding the joints for rheumatoid arthritis classification, the ER studies already, and we feel that our algorithm may be able to also quickly be able to do bone age. And bone age is important in quite a few aspects. And I know they use it even in the legal courts sometimes to understand a person's true age, or also relating to different types of diseases based on the bone. You're able to understand the. So we got a normal age, and we also got a sort of like a lifetime age, like a health age. And so just to understand the age from that perspective, based on the bones, how old is the person, or the younger than what the true age is, or older, what are the bones saying? So yeah, we may actually, once we complete this project in rheumatoid arthritis, we may actually also venture into looking into bone age. So in summary, right, overall our accuracies without the balancing was 96.41%. With the ±1 balanced accuracies, it ranged from 91.51% to 97%. And the current impact is that it's an automated tool, right? Because the code actually just is able to score the joint damage quite swiftly and actually quite quickly, less than a minute. It's quite quick, the scoring, and it provides it's highly accurate and quick measurement of the joint damage. So in fact, it's not only highly accurate and quick, it's also the fact that it is more consistent because it's quantitative versus current practice where it is more subjective, time consuming and expensive. With this algorithm, the clinicians will be quickly, in less than a minute, be able to score the joints and be guided by that score. So it's not that the algorithm is the right, it's the clinician can be guided by that score to make a diagnosis or to provide treatment for the patients, which means that the patients can be detected also earlier with rheumatoid arthritis, which means from a societal point of view or from a national point of view, the amount of cases of rheumatoid arthritis can actually reduce, in particular in terms of the severe cases, could potentially reduce. And we also see some other future impacts. That is, it can aid research. You find that, for example, different rheumatoid arthritis rheumatologists, how do you say, give different treatments to their patients, right? And it's not so easy to understand which treatment performs the best for the different levels of rheumatoid arthritis. And so through this algorithm that we have, we believe that, research or even a clinical trial can help to understand more about which treatment works better for which types of rheumatoid arthritis patients. Okay, I see that gives an objective measure and of course better for disease management. So that's my my presentation in terms of how we are using, in this case, several techniques. In terms of deep learning, we are using, technology to extract mask and extract joints, and also to predict and score joints And we believe that this is just the beginning. The technology is rapidly improving. Even I think the versions that I used here are probably very different now. I do know there's a different, YOLO and a different, VGGs, these much higher versions. So possibly much faster, possibly even, more accurate and more user-friendly to use. So we're looking quite forward to the results of our current project with the clinicians. So I'm open to any questions, and thank you for listening to me.
Thank you, Madam Carol. You have given very nice talk, and I think you have given a very nice application in the area of rheumatoid arthritis. That is a burning issue related to health. And you have given the application of the deep learning in the area of the health issue related to arthritis. Problem is a very common problem nowadays because of the self-defense system does not work in the body. Then it happens to take place. So, Mr. Sanghars, you have any questions in the message box?
Sir, there is no question.
Okay. So, Madam Carol, you have given very nice talk, and please keep on giving your cooperation to us in future also. And thank you very much once more for your nice deliberations. Still, if we have any queries, then I'll forward it through email or something.
Okay.
And be elaborated. So thank you very much, madam.
Thank you too for giving me the opportunity.
Thank you.
Bye.
Bye. Okay, our next speaker is not available. Our next speaker, Professor Ghimre from Nepal, is not available. So this session is closed, and next session will start. That is the paper presentation of the research scholars and faculty members. This will begin at the time 2 p.m. and from this time to 2 p.m. is the break time. And thank you for joining, and please do join 1:45. All students are requested, all faculty members, all participants are requested to join at 1:45. Okay, thank you very much.